In today's class, we will be talking about a laboratory equipment called pH meter. So we'll start by looking at what pH means. So pH is defined as the negative logarithm of the hydrogen ion concentration or activity in a solution. pH meter is an instrument used to measure the pH, which is the acidity or the alkalinity of a solution. Or a pH meter is an instrument used to measure hydrogen ions activity in solutions. The pH meter does this by measuring the difference in electrical potential between the pH glass electrode and the reference electrode, and therefore sometimes called a potentiometric pH meter. The pH meter measures the acidity or alkalinity of a solution and measures pH on a scale of 0 to 14. The proportion of hydrogen ion to hydroxyl ion determines the solution's pH value. So if the concentration of the hydrogen ion exceeds that of the hydroxyl ion, the substance is acidic. That's a pH lower than 7. The substance is neutral if the concentration of the hydrogen ion and the hydroxyl ions are equal. So that's having a pH equal to 7. And the substance is basic if the hydrogen ions is less than the hydroxyl ion. And in this case, pH is higher than 7. So this is the pH scale over here. So from 0 to 6 is an acidic medium, and from 8 to 14 is an alkaline or a basic medium, and pH 7 is a neutral pH. So from 6 to 0, there is an increase in acidity, and also from 8 to 14, there is an increase in alkalinity. Basic instrumentation of the pH meter. A pH meter has 3 main parts. So 1, the measuring or glass electrode; 2, the reference or standard electrode; and 3, a high impedance voltage. So these are the 3 basic parts of the pH meter. So let's look at the functions of each part. So we'll start by looking at the reference or the standard electrode. The basic function of the reference electrode is to maintain a constant potential as a control for measuring various different potentials. So now let us look at the glass or the measuring electrode. The function of the glass electrode is to establish a potential difference that responds to changes in the hydrogen ion activity of the measured solution, or in other words, the glass electrode helps to measure the potential changes across the glass membrane. We also have to note that putting the pH glass electrode and the reference electrode in the same solution forms a primary cell, and the potential of the cell is the algebraic sum of the potentials of the glass electrode and the reference electrode, which can be expressed as this. And what we also have to note is that the voltage produced between the 2 electrodes is proportional to the pH of the solution. The voltmeter. The voltmeter is attached to the pH electrodes and measures the minute or minimum electrode voltage and displays the result directly in pH units on the analog or digital display. the filling hole, and this is the filling hole of a pH meter. The filling hole is an opening used for refilling electrolyte into the electrodes. The probe. So this is the probe. The outer layer of the pH meter is the probe. So what we are seeing over here is the probe. So the probe contains the two electrodes for measuring the hydrogen ions activity in the solution, and in some cases the temperature detector. The temperature detector in the probe helps to detect the temperature of the solution. So now let us look at the glass electrode. So first of all, what you have to notice is that the glass electrode consists of a silver wire which is coated with silver chloride and dipped in an internal solution or electrolyte. And the electrolyte is 3 molar potassium chloride of pH 7.0, making it neutral. The bottom of the probe is specifically designed bulb-like to act as an ion selectively glass membrane, and also has a liquid or a gel layer around the glass membrane. So this is the liquid or the glass or the gel layer which is around the membrane. The glass electrode is the electrode close to the test sample and allows ion exchange between the test samples and the electrolyte. So as we can see, this is the outer glass membrane which is in contact with the test solution or the test sample. And this is also the inner glass membrane which is in contact with the electrolyte, which is the 3 molar potassium chloride of pH 7.0. So when dipped into a test sample, hydrogen ions from the test sample move to surround the outer walls of the bulb. Ions from the electrolyte moves to the inner walls of the glass bulb. So if the hydrogen ions from the test sample is more than that of the electrolyte, the sample is acidic. And if the hydrogen ions from the test sample is less than that of the electrolyte, the test sample is basic. And if the hydrogen ions of the test sample is the same as that of the electrolyte, the test sample is neutral. The reference electrode. The reference electrode consists of a silver wire coated with silver chloride and dipped in an internal solution or electrolyte of 3 molar potassium chloride at pH 7.0. The electrode consists of a filling hole, and this is the filling hole over here, which is used to refill the electrolyte into the electrode. It also has a junction made up of a porous ceramic membrane or a diaphragm that allows ion in small amount from the electrolyte into the test sample to create difference in electrical potential or voltage between the glass electrode. The reference electrode function is to keep a constant potential in any solution. The difference in the electrical potential of the pH electrodes will cause electrons, which is current, to move from the reference electrode to the glass electrode. And according to Ohm's law, we know that current is proportional to the voltage. The voltmeter then measures the voltage produced and display it as a pH value according to the next equation on the display meter. Working principle of pH meter. The primary working principle of the pH meter is based on the exchange of ions from the sample or test solution to the inner solution or the electrolyte of the glass electrode through the glass membrane to generate electric voltage, which is measured by the pH meter and converts to a readable pH value. Therefore, the result of the pH meter is based on the combined relation between the electric voltage, the ion concentration, and the pH reading. Storage of pH meter. The best way to store a pH meter is to store in 3 molar potassium chloride or a buffer pH of 4 or pH of 7, or in a 0.1 molar HCl. And what we have to note is that we should never store the pH meter in distilled water or dry, as this can affect the pH glass membrane. Care and use of the pH meter. 1. The pH electrodes are sensitive and fragile, so one should not use them as a glass rod to stir the solution whilst measuring pH. 2. pH meters should be calibrated daily before use with the help of a standard buffer solutions of pH 4 or 7 or 9. 3. pH readings are temperature sensitive, so pH meters should not be exposed to sunlight. 4. All the test tubes and glass apparatus used in measurement should be cleaned with distilled water before use. 5. Solutions to be tested must be thoroughly mixed before its pH measured. And 6. The pH electrode must be washed in distilled water before and after use and must not be touched with the fingers. 7. After each measurement, rinse the pH electrode with distilled water. And 8. Never wipe the glass membrane or probe of the pH meter dry with a paper towel, since this will damage the pH sensitive membrane. Maintenance of the reference electrode. So this is the picture of the reference electrode. This is the filling hole. This is the permeable porous junction or the diaphragm. And this is the silver wire, which is coated with silver chloride, and this is our reference electrode or internal solution, and this can be the 3 molar potassium chloride of pH 7.0. Now, so 1. Replace or refill electrode regularly. 2. The electrolyte level must be higher than or be above the electrolyte junction. Otherwise, samples will flow into the reference system, resulting in wrong results. 3. There should be no air bubbles behind the junction, as this will restrict the electrolyte flow. And 4. For aqueous solution analysis, 3 molar potassium chloride should be used, and for non-aqueous solutions, 1 molar lithium chloride in ethanol should be used. How to calibrate the pH meter? It is essential to calibrate the pH meter and with the appropriate buffer before measuring each test solution. Mainly, more than 1 buffer solution is required to calibrate the pH meter. The first one will be a neutral buffer with pH 7.0, and the second one should be near the expected sample, either pH of 4 or pH of 9. And also, buffer with higher pH, that's around 9.0, are best for measuring bases, whereas buffer with lower pH are best for measuring acidic samples. The procedure to calibrate the pH meter includes the following. 1. Rinse the electrode with deionized water and blot it to dry. 2. Maintain the temperature of the buffer and solution at 25 degrees Celsius. 3. Immerse the electrode in a buffer solution of pH 4 or pH 7 and make sure the entire electrode is immersed in the buffer solution. So 4. Slowly stir the buffer solution to create a homogeneous mixture. And 5. Enter the car or the measure button to start the calibration. 6. Wait for pH to stabilize and press hold and enter key to stop reading for further fluctuation. And now the meter is calibrated. Finally, watch the electrode with the buffer, which is further used to determine the pH of the test sample. Why the pH meter needs to be calibrated? pH measurements are made by comparing the pH reading of a sample solution to that of a reference solution with defined pH, such as buffers. Therefore, it is important to calibrate the instrument with appropriate buffer solutions before making any measurements. How to use the pH meter. 1. Turn on the pH meter and wait for an adequate time for it to initialize. 2. Remove the electrode from the storage solution and clean it with deionized or distilled water. 3. After rinsing, blot the dry electrode with non-abrasive clean wipes to remove any excess water. 4. Maintain the temperature of the sample at 25 degrees Celsius for appropriate reading. And 5. Place the electrode in a test solution. Stir the test solution and also press the measure button to measure the pH value. Then wait until the reading gets stabilized for 1 to 2 minutes. Once the reading gets stabilized, press the measure button and record the pH value with the temperature. When done, remove the electrode, rinse it with deionized or distilled water and blot dry with a clean wipes. Lastly, immerse the probe in 3 molar potassium chloride storage solution.